Hello again. As we promised you, we are going to come back to you with several sessions about the midfield terminal building. This is part one of the execution phase. We have seen previously the definition of the project, the introduction to our BIM capabilities, and also the introduction about the size, complexity, and challenges in that project. Now, the project was awarded in 2012, and luckily we were ready with resources, standards, procedures, and systems. Now we should come now to the real pattern, how we are going to leverage this and take it to the construction phase. If you remember in the previous session, we talked about the complexity of that project. What you see in front of you are different examples of the complexity in the structural, and the architectural, and the MEP, and the services, and the systems, and the cladding of that project. You can see how complex is the geometry of that roof. And if you see that roof closely, you'll understand that you can hardly find similarities between different panels. The same here. You can see different steel members having different sizes, different orientations, and really you can find difficulty in finding similarities. The same applies to these huge arches which is carrying the roof cladding, the roof of the project. And you can see different images that illustrate the complexity of that project. To be able to leverage all this complexity in one system that can address this kind of difficulties, based on our experience, we opted to use Bentley Ecosystem as our main authoring platform for that project. Why we opted to use that? We've been working with Bentley since 20 years. And we managed to generate all kinds of projects and all kinds of geometrical complexity, all kinds of disciplines so far in that project. So this was one of the reasons that we selected Ecosystem, because we have the background knowledge, the skills. Second thing, we found that Bentley is a robust system. This robustness makes us feel more confident that it can accommodate the size and complexity of the midfield terminal building. Also, we had developed over the last 20 years a lot of automation tools and sets of applications that were developed on top of Ecosystem that could help us develop this solution further and make us more productive, more effective in building such complex projects. That's why those are some of the reasons we use Bentley as our main authoring solution. At this point, I want just to emphasize that we did not force any stakeholder to use Bentley as well. And we managed to find between each and every stakeholder and Bentley means to translate data, geometry, and attributes from the stakeholder application to Bentley. One of the major beliefs that we have about BIM is to have an effective BIM implementation, BIM should be the main place where you host the scope. If you don't have scope captured in your BIM model, definitely your BIM implementation will not reach far in your workflows. So as such, we always insisted and we always believed that BIM should be capturing and managing the project scope. And of course, MTB was a great example for that. What you see in front of you is one of the extracted material takeoff reports that were generated from the BIM direct to the stakeholder who was interested in that report. And just to give you an idea how that BIM was very effective in that process, at the beginning of the project, there was 60 QS engineers assigned for that project. Because we had BIM implemented successfully there, we reduced the number of QS engineers from 60 to 6. And this gives you a 90% reduction in direct cost and direct resource wages. This is really a very good illustration that if you use BIM properly, you can reduce the cost and you can make your process more effective and more efficient. And definitely from the beginning, since we know that the client is looking about his assets and for him the airport is an asset. All the components of the airport are really important assets for the client. We need to find a way to capture these assets from day one. Not only to make sure that we are answering the client needs about asset management and facility management, not only that. Because unless we have and create unique object identifier between the different assets and the other systems, we will not be able to integrate BIM properly with cost, with time, with quantity, with quality, with many other applications. And this is jeopardizing our intentions to have a complete and integrated BIM platform to run the BIM process effectively for all the stakeholders during construction and beyond construction. And as such, we have developed a lot of procedures, a lot of workflows, a lot of tools that helps us in naming and giving unique identifiers for each and every component, each and every element, and each and every asset. What you see in front of you is just an example of the object naming convention. This is what we call it a member mark. In our definition, for you, you can call it asset tag or object tag. And what you see here is an integration between the work breakdown structure. As you know, the work breakdown structure is the method where the construction process is happening. And disciplines, for example, this is MTB, this is the name of the project. As you can see, this is level 1. This is the building, which is beer number 3. This is the floor, first floor. This is structural concrete. And this is the column. And this is the unique number of that column. And what you can see is the concrete quantity and the formwork quantity. This is a great example of how we managed to integrate the quantity surveying process and the scope process with the BIM. And this unique identifier will be the key for integrating that column to all other workflows such as quality, control, time, all what we talked about earlier. Since we have a lot of information generated and captured during the construction process, how shall we capture this information in a secured and structured place? How we are going to manage this information in secured and structured place? And how we are going to share this information between the different stakeholders? That's why collaboration was really a necessity for the success of the BIM process. For collaboration, we used an industry application called ProjectWise. This is like a document management solution, and moreover, it's a very effective BIM management solution. Why? Because it can realize the BIM files, it can realize the library related to the BIM files, it can realize the associated reports to the files, and any reference files associated with the BIM authored file. So it was very important for us to make sure that all the stakeholders, subcontractors, the client, designers, have access to that platform where information is updated through a document-controlled process. So we don't just update documents or models to ProjectWise without being controlled and checked and verified. And this is very important to understand and make sure it is happening, because if you don't secure integrity and information quality, you are jeopardizing a lot of the functions in the project. So all the stakeholders were following also a certain workflow for producing models, reviewing models, and then publishing models to the different stakeholders, different subcontractors and different suppliers. And then the final model will be, once it is approved, will be sitting exposed to all those who are supposed to view and use that model for any process like design coordination or material takeoff or clash detection or whatever. Now, we believe that collaboration is not only a digital collaboration. Collaboration should happen in two different levels: physical collaboration as well as digital collaboration. For digital collaboration, we described the ProjectWise as a platform for exchanging data digitally and sharing it digitally between the different stakeholders. For physical collaboration, which was very important in that project, we have developed what we call it the iRoom. The iRoom is what you see in this picture. It consists of 9 big screens with a total distance or total dimension of 4 meters by 2.4 meters height. These 9 screens are connected to 9 different touchscreen computers sitting on this round table. Each computer is connected to one screen. So assume that we have 9 different subcontractors sitting on the same table. Each one has his own problem in one area that we are going to construct next week. So each of these subcontractors is displaying his problem in one of the screens. And then once we decide that we want to discuss it all together, we augment all the models together, and you have the screen is full of one model that integrates the 9 different models on the same screen. This was used effectively for discussing problems, advising solutions if possible, creating RFIs if we could not reach for a decision about an effective solution for a problem identified during the design coordination process. This is one of the really important achievements in this project, because we managed to reduce the number of days required for an RFI, in some cases from 28 days to 2 days. And this was really important for the construction team. At this point, I will end the first session of the execution phase, and I promise you I'll give you a second section in the next time. Thank you.